This is problem number 47, chapter 6. It's on page 128. And it says, only 5% of babies have learned to walk by the age of 10 months. 75% are walking by 13 months of age. The age at which babies develop the ability to walk can be described by a normal model. So I'm going to have n. I need to find the parameters, some mean and some standard deviation. So I know I have 5% at 10 months, and I have 75% by 13 months. So I'm going to make a normal model. Here's my normal model. I have some mean, which is as yet unknown. 1, 2, 3 standard deviations to the left. 1, 2, 3 standard deviations to the right. Now, one thing I know, because is that from my second standard deviation negative to my second standard deviation positive, it encompasses 95% of all my data. I'm taking 95% out of the middle, so that means this piece right here, this last little piece from the second to the third standard deviation is 2.5%. That way, it's 2.5% that way, from the negative third to the negative second standard deviation. 3 minus 2 minus 1, 1, 2, 3. So if I know that 5%, well, let's put over here. This is 0 months. Way over here is infinity months. People who never learned to walk. So 10 months is going to be 5% of my data. Well, I know that 2.5% of my data covers all that. So my line for 10 months is going to be somewhere between the first and the second standard deviation. This is going to be 5%. From the third to the second only encompasses 2.5, so somewhere between the second and the first is going to be 5%. Now 75% are walking by, that's this 5% right here. 75% are walking by 13 months. Well, I remember from doing our IQR problems that the 75th percentile is about 0.67. So I know it comes right about here. So this is the 75th percent, and this is 13 months, and this is 10 months. I've got a little bit of information here, but I still have to figure out how to find out what is the mean and what is the standard deviation. Well, let's do a little bit of work with z-scores. See if that'll help us out at all. When I have a percentile, I can get a z-score. My z-score for 5%, I'm going to go second, bars, 3 inverse norm. I'm going to put in 0.05. I'm going to find out that that z-score is negative 1.6, call it negative 1.64. And my z-score for 13 months is a 75th percentile. So second, distribution, 3, and I'll put in 0.75, and sure enough, it's going to come up our 6.67 z-score. 0.67. So now I'm going to have to do a little bit of algebra. I know that z is equal to y minus y bar over s. So on the 10-month side, I know that negative 1.64 is equal to my y, which is 10, minus y bar, which I don't know yet, over s, which I also don't know yet. And on this side here, my 13 months, I know that 0.67 is equal to 13 minus y bar over s. Still have two variables, but now I have two equations. I have this equation, and I have this equation. And if I have the same number of equations as I have variables, I can use some algebra to solve this. Here's what I'm going to do. I'm going to multiply both sides of my equation here by s. So I'm going to get negative 1.64s is equal to 10 minus y bar. I'm going to isolate y bar. So I'm going to subtract 10 from both sides. So I'm going to get negative 1.64s minus 10 is equal to negative y bar. And on this side, I'm going to do the same thing. I'm going to multiply both sides by s. I'm going to get 0.67s is equal to 13 minus y bar. And I'll subtract 13 from both sides. I will get 0.67s minus 13 is also equal to negative y bar. Well, what do you know? I have y bar over here, and I have y bar over there. And since I know that they're the same, I can set these two other parts of the equation equal to one another. So I know that negative 1.64s minus 10, that is equal to 0.67s minus 13. Now I just have one variable, and I can solve this. What I'm going to do is I'm going to add 13 to both sides. So I have negative 1.64s plus 3 is equal to 0.67s. The 13's canceled each other out. Well, I want to isolate s. So I think what I will do is I will add 1.64s to both sides. And I will be left with 3 on this side. And on this side, I will be left with 2.31s. Let's divide both sides by 2.31. Calculator. I say get my calculator. I go 3 divided by 2.31. So my s is equal to, well, let's go 1.30. So now I have part of my normal model. I have the standard deviation part of my normal model. Can I fill that in? Yes. So I have n something 1.30. But calculating that something now should be pretty easy, because I know that I could just take this part of the equation right here. Negative 1.64 z-score is equal to 10 months minus y bar over s. Let's see if it'll let me copy this. Let's bring it down to the bottom. There it is. Okay, so we can change that to be negative 1.64 is equal to 10 minus y bar over, now we know it's 1.30. Let's do the math. Negative 1.64 times 1.3. That gives us negative 2.132 is equal to 10 minus y bar. If we subtract 10 from both sides, I get negative y bar is equal to negative 12.132. So my mean, since they're negative and negative, I can multiply both sides by negative 1. Y is equal to 12.13. Y bar is equal to 12.132. And 12.132, let's go back up to the top. 12.132. That should be our normal model. And in fact, that is the correct answer, or close up given some rounding errors.